In this video, we're going to look at number 5 from the 2019 AP Statistics test. It says a company manufactures smartphones. They developed a battery that has a longer lifespan. From the data purchased, the distribution is approximately normally distributed for the lifespan with mean of 30 months, that's important, and standard deviation of 8 months, that is also important. For a price of $50, the company offers a 2-year, 24-month warranty. Within that warranty period, the company will replace the battery at no cost to the customer. Okay, so we've got approximately normally distributed data, and so we've got a mean, and we've got then approximately 50% of the data fall on the right and 50% fall on the left, since the mean and median are the same in normally distributed cases. We've got 34% of the data within this first standard deviation to the left. That's important looking at A. And how many months from the data purchase is it expected that 25% of the batteries will no longer work? All right, so in this case, we got 50% of the batteries will break within 30 months. And so subtracting from that 34%, which is our first standard deviation, we see that 16% of our batteries are going to break within 22 months, which is 30 minus 8. Right? So we know that we're somewhere between 22 and 30, of course, and in fact we're going to be a little bit further up from 22, since we're looking at Z for 25% of the batteries, which is basically saying that if you're a customer and you buy a phone, then there's a 25% chance that your battery won't work within this time period. And so we're looking for a probability. For the probability, Z is less than or equal to whatever number this is here, X, or whatever you want to call it. And this is going to be negative, the probability is going to be 0.25. Right? And of course we're looking for negative z-score since it's to the left of the mean. So let's look at the tables that you can find on this test or in any statistics book, and I've got them highlighted already. So we have between negative 0.67 and 0.68, we've got 0.2514 and 0.2483. Now that's not perfect, and so we're going to have to do a little bit of arithmetic just to find out a number that's a little bit closer. So basically in this, let's blow up this area here. We're going to have, we've got two possible places here. We've got negative 0.68 and negative 0.67, and our number lies somewhere between these. And it's not quite half because we had, what, 2.2514 and 0.2483. And there's a little bit of a difference. We're looking for 0.25. So we need to move 0.0014 from this number, or we need to move 0.0017 from this number. Right? So we're going to take that and find the mean, or sorry, the difference there is 0.0031. Okay, and so we want to find out what percent does that number represent compared to the difference. So we'll have 0.0014 divided by 0.0031, and we get 0.45 or 45% of the way that we have to move between these two. All right, so we've got to move 45% of this line here, which again is an approximation because this is not exactly a linear function between the two, but it's close enough. Right, so we're going to say then our z-score is negative, and we'll take that 0.67 and we'll tack on to that 45% of the difference between the two. And then we're going to take that z-score and find out what our number is in months. So to do that, we are going to take our standard deviation, which is 8, and we're going to multiply that by the z-score. Z is negative 0.6745, and we're going to subtract that from the mean, which is 30. So the mean minus z times the standard deviation, or plus the z-score, anyway. Minus z times the standard deviation is equal to 24.6. So these two numbers the math came out to be 5.396. This is 30. 30 minus 5.396 is approximately, we'll say, approximately, roughly equal to 24.6. All right, so 24.6 months is the time in which we can expect that 25% of the batteries no longer work. So if you are a customer and you purchase one of these phones, then there's a 25% chance that your phone will break within 24.6 months, which is just after the period of time that the warranty expires. Let's look at B. Suppose one customer who purchases a warranty is selected at random. What's the probability that the customer selected will require replacement within 24 months of the date of purchase? Remember, 24 months is just less than the number we just found, which is 24.6 months. Okay, so we have, again, approximately normally distributed data. Excuse my tablet illustrator here is not exactly up to date. And so we've got 24 months is 0.75 times the standard deviation. So 0.75 standard deviations from the mean, right? 30 minus 24 equals 6. 6 equals 0.75 times 8. Okay, so we're looking at negative 0.75 standard deviations. Okay, so we are looking for then the probability that the phone breaks within 0.75 standard deviations to the left of the mean, which means a z-score of negative 0.75. This one's pretty straightforward. We'll go down to the tables again. Negative 0.75, that's this one here. 0.2266. So there is a 22.66% chance that if you buy a phone with a warranty, then that warranty will cover the purchase, cover the cost of your battery because it's going to break within the term of that warranty. 0.2266. So 22.66% of customers who purchase a warranty actually use their warranties. So that's really not so great either, or not so many. Gets us to our third part of the question. The company has a gain of $50 for each customer who purchases a warranty but does not require replacement. The company has a loss or negative gain of $150 for each customer who purchases a warranty but does not require replacement. Sorry, but does require replacement. What's the expected value of the gain for the company for each warranty purchased? And so then if the battery breaks in a time of less than or equal to 24 months, the company gains negative $150. And if the time, it takes for the battery to break is greater than 24 months, then the warranty is not activated, and the company actually gains something, which is $50, or the cost of the original warranty. Okay, so we've got to figure out the actual gain for the company. Well, so what chance is there that the battery breaks within 24 months? We just figured that out. That's 0.2266. and we're just going to multiply that by the gain, or what really a loss. So there's a 22% chance that the phone battery will break within the term of warranty, which indicates a loss for the company. And we're going to add to that the chance, the probability, that the phone battery breaks after the term of warranty. Well, so if here's the chance that it breaks within the term of warranty, everything else is after the term of warranty. So we're just going to say 1 minus 0.2266 and multiply that by the gain, which is $50. So that's pretty simple math. So we've got the gain then is equal to, I'll switch the order around here and give you $50 times 1 minus 0.2266, which is 0.7734, and we're going to subtract from that $150 times every phone battery that breaks and needs to be replaced under the warranty. And so hopefully this number, hopefully for the company anyway, this number is greater than this number. And if the company is smart about its strategy in pricing the warranty, then in fact it will be greater, and what we end up is $4.68 is the estimated profit from each warranty sold, which is not a whole lot. And so the company needs to make sure that its phones are probably Six Sigma in production, and so there's not a lot of variance in quality such that they can count on these probabilities being fairly firm. And I say, well, I suppose we can say approximately. Because if there's a lot of variance in quality, then this margin could easily be eaten up if this number grows and this number diminishes. On the other hand, for a customer, right, is it profitable or is it wise to buy a warranty? Well, there's only a 23% chance that your phone battery is going to break within the term of warranty. So if you spend $50, there's a relatively low chance that you're actually going to have to use that warranty. But in the case that your phone does break within that period, although it's relatively low chance, then you will actually save some money, right? You'll cost the company some money. And so, but there's a 77% chance roughly that your phone is not going to break within the term of warranty. So if you're a customer, well then, it's kind of a hard decision. And if you're the company, if you're relying on this margin, then you need to make sure your production facilities are seriously up to date and probably Six Sigma.